There's two trends you need to know. And the trend is just something that follows a pattern. So for the periodic table, as we go across a period, and periods are horizontal, as we go across a period from one atom to the next, the nucleus gets stronger. Now if the nucleus gets stronger, it's going to pull electrons closer to it. Now an atom is defined as where the electron is. The size is defined by how far out the electrons go, essentially. So my trend as I go across for size, well, if this atom is relatively weak, the electrons go around it. They don't get too close. But this one is stronger, so all of the nucleus pulls the electrons closer. So I have a fairly large atom here. More protons pull the electron closer to it. And here, lots of protons pulling in those electrons. They're going to keep them very, very close. So we say my size, or the size of the atoms as we go across, decreases. Now, I didn't draw this very well. The nucleus got larger here. But we know when we have an atom, the nucleus size of the nucleus is really small. It's really all about the electrons. Alright, so more accurately, make that a little bit bigger. Okay, so size decreases as you go across. So that means if I have any two elements, well, like sulfur and bromine, that's where they are on the periodic table. So since size decreases as I go across, I know sulfur is larger than bromine. Now I also have to consider, as I go down a group on the periodic table, what happens to size? Well, the important thing as we go down a group, the first level has one shell. The third level has 3 shells. All the way down, I can get to level 6 and 7, which has more and more shells. Okay, each shell adds a layer to the atom. So clearly I can see as size as I go down a group, size increases. So if I had two elements on the periodic table, bromine is above iodine. As I go down, size increases. So I know iodine is going to be larger and bromine is going to be smaller. Alright, so if I had sulfur and chlorine again, I just look, one's to the right of the other, size decreases as I go across. So this guy is going to be smaller than sulfur. Going vertical, it gets larger as I go down. So if I had something like chlorine and bromine, chlorine is above bromine on the periodic table. They get larger as I go down the periodic table. So bromine would be the larger atom. The other trend we need to know is electronegativity. Now, electronegativity is basically how strong an atom is, the pull on an electron. So again, as I go across, we know the trend is I'm adding protons. Okay, well, just looking at this, electronegativity, just looking at this, which one do you think would pull the electron with the greater strength? Well, obviously, if I have 6 protons pulling versus 1, this is going to be a stronger atom. Strength, electronegativity, we're going to use those interchangeably. So our electronegativity as we go across, we say is increasing. The strength is increasing. So if I have two atoms like sulfur, chlorine, that's where they sit on the periodic table. Okay, chlorine's to the right. Electronegativity increases in that direction, so chlorine is stronger. As I go down a group, the the most important thing is shells. I have 1 shell, down to 3 shells, and then I can get to 6 or 7 shells. So we're asking which one pulls on an electron the most? Well, this one, the electron's right there, right in front of that nucleus. He's going to pull on it with a lot of force. Well, here my nucleus is inside. I have all of these electrons. I could have a ton of electrons. I could have 50 electrons in here. And so with electronegativity, I'm asking, when this guy comes by outside of the atom, how strongly is the nucleus going to pull on it? Well, we know pluses and minuses attract. Minus repels minus. So if I have all of these negative electrons here, I'm actually going to kind of keep this guy away. So normally my nucleus would be attracted to that electron, but it's shielded by all of these other electrons. This nucleus can't even really detect that electron. It's just surrounded by negativity. So this guy's going to pull it in a lot easier. So we say this guy is stronger. So his electronegativity is stronger, is greater than this one. So our trend for electronegativity as we go down a group is that electronegativity will decrease. So if I have bromine and iodine, well, electronegativity decreases as I go down a group. That means this one is stronger, this one is weaker. So we would say this one has a higher electronegativity. If you get confused, just remember on the periodic table, fluorine up here is the strongest atom. He has the highest electronegativity of all. And for all intents and purposes, cesium is the weakest. Alright, just from there you can tell weakest to strongest, electronegativity increases that way and must decrease that way.